Today, we will be looking at implicit statistical learning ability in L1 sentence processing by Lee. Before we begin, we will need some terms and concepts. Adjacency rules imply information about neighboring linguistic elements, where non-adjacency rules imply information about non-neighboring linguistic elements. These are usually elements of long-distance dependencies. As you will see, this study had two main components. The first was an artificial grammar learning task. Artificial grammars are paradigms involving synthetic rules that govern a made-up syntax for nonce sentences made of simple nonce words. The task is for participants to assess the grammaticality of given nonce sentences. The second component was a self-paced reading task. These display words on screen one at a time. Participants choose when to move forward by pressing a button to move on to the next word. There were two main research questions. The first, they test if participants can learn both adjacent and non-adjacent dependency rules from a sequential input AGL task. They then see if a strong AGL performance implies a strong performance on naturalistic tasks.
It was already established that people can learn artificial grammars, but whether these AGL abilities correlate with natural language acquisition was not sufficiently established. A couple of studies have shown SL abilities' relationship with online sentence processing. However, methodological issues diminish their generalizability. Thus, the aim of this study was to examine SL abilities' role in L1 English sentence processing. Now to get into the methodology, the researchers sampled 44 adult native English speakers. Each completed 2 AGL tasks and 2 self-paced English reading tasks. One AGL task involved an adjacent dependency rule and the other involved a non-adjacent dependency rule. Analogously, one reading task evaluated local dependency processing and the other evaluated long-distance dependency processing. In particular, the researchers used number agreement constructions and object relative clause processing respectively. As training for the AGL tasks, the participants were familiarized with sentences from an artificial grammar. Each of the AGL tasks were then carried out as follows. They were asked to judge the grammaticality of 40 sentences, half of which were grammatical. A participant's SL ability for each type of syntactic relation was proxied by their accuracy on the relevant task. In the number agreement dependency task, participants were asked to assess the grammaticality of sentences which either exhibit or violate number agreement. In the object relative clause task, participants were asked a comprehension question to assess if they understood the relationship in question.
Lastly, we will be talking about results and implications. The results concluded that both scores for non-adjacent and adjacent dependency learning tasks was higher than chance level. This overall means both groups were sensitive to the artificial language, confirming the validity of visual statistical learning. However, the participants' success on the AGL tasks can only partially be applied to the natural languages, as results showed that adjacent AGL scores were a predictor for number agreement tests. On the other hand, non-adjacent AGL tasks were not correlated to comprehension accuracy. The implications of this study is that though the results of this experiment are consistent with previous similar experiments, such as the saffron experiment, this experiment presents two puzzling findings. Firstly, native English-speaking participants scored higher on comprehension accuracy filler sentences compared to object relative clauses, which suggests that the participants were paying more attention to the experimental materials. Secondly, there was no correlation between statistical learning and processing ability found in non-adjacent dependency rule. This might be a result of artificial grammar tasks having no meaning, whereas object relative tasks include a level of comprehension due to the task including the interpretation of form meaning mappings. This study suggests that the correlation findings of processing artificial language and natural adjacency dependency structures imply similarity in the processes used in learning them.